Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good day to everyone. So in this video we discuss about differentiation of trigo functions. Right. So this is the formula for differentiation of trigo function. Right. So the first one, differentiate of sine will get cos. Second, differentiate cos will get negative sine. So remember, for cos differentiate we have negative sign. Right, next tangent. So differentiate tangent will get secant squared. And then fourth, differentiate cotangent will get negative cosecant squared. Fifth, differentiate secant will get secant times tangent. Then lastly, differentiate cosecant will get negative cos secant and cotangent. So remember, among these three, there are three terms that will have a negative, right? So the first one is differentiate cos will get negative sine. Second, differentiate cotangent will get negative cosecant squared. And then lastly, differentiate cosecant will get negative. Right, and then coincidentally, if you notice, at odd, even, so we'll get negative. So this is the second, the fourth, and the sixth. So the even, according to the sequence here, will get negative. So that's the tip how to memorize which one positive or which one negative. But for example purpose, I think the formula already given, should be no problem. And then notice below there, differentiation of the above formula are only true for angles which are measured in radian. Okay, so highlight the radian here. So make sure that you notice that angle must be in radian. So make sure your calculator set into radian mode. If you later on will need to sub values. If just like x, no problem lah. But later if you want to sub values, so make sure it will be in radian. Right, so let's try to answer this question using the formula. So I list out here. This is the formula that may be useful to solve these three questions. Right, so we start the first one. So the first one, oh yeah, notation. So don't forget the notation. So notice that here we don't have y. So if you want to differentiate, you have to copy ddx here. So you copy down like this. So ddx of 2 sine x minus 3 cos x. Then we can differentiate. If you do want to do ddx here, you can let y, no problem. Okay. But do not simply do dx. That one is wrong because we don't have y here. If you have to put y, so you have to let y first. If not, you just put ddx above like this and then in bracket. So copy down the question like this one. Right. So move on to the differentiate this one. Right. So here we know differentiate sine will get cos. So here will be 2 cos x. And then next we have cos. So we know differentiate cos will get negative sine. So negative 3. So here is negative sine. So the answer should be 2 cos x plus 3 sine x. Okay. Right, next for second question, we have 4 tangent x. So don't forget, you have to copy down the question and then put ddx at the front. So differentiate for this one, we know differentiate tangent. So look at above there. So differentiate tangent will get secant squared. So for 4, the coefficient just follow. So tangent will get secant squared. And then here, don't forget, so 5 over x is actually 5x power of negative 1. So minus 5 and then negative 1. So original power x power of, so negative 1 minus 1 is negative 2. Right? And then we can simplify, negative negative will get positive, and then we can bring negative, put it below. So the answer would be 4 secant square x. This one is 5 plus, plus 5, and then x squared we put below like this, so be over x squared. Okay. Right. So lastly, we have 4 cos x plus 3 cosecant x. So don't forget, we have to write down the notation for ddx. So copy down the question, 4 cos x plus 3 cosec x. So we know for cos we'll get a negative sign. So 4 times negative sign x. And then for cosecant, so look at here below there. So for cosecant, we have negative cosecant cotangent. So plus 3 times negative cosecant x cotangent x. And then lastly, we expand the negative, also the negative here. So at the end, we got negative 4 sine x minus 3 cosecant x cotangent x. Okay, so this will be the solution for example 16. Right. So now look at the derivative. If we have a function inside the trigo, so let's say u equals to fx. So in this case, apart from differentiate, for example here, differentiate sine will get cos. So don't forget the function also need to differentiate. So that's why it's notated by du dx at the back here, means that the inside function here also need to differentiate. So that's why you will get du dx at the back. So I think I do not need to describe in detail for each formula here, because it is same as the previous one, except here we have to also differentiate the inside function. Right. So now look at the example here. Find the derivative of these 4 questions. So let's see the solution. Right, so the first one. Okay, as I said in the previous example, since the question didn't have y equals to or fx equals to, so you have to put a notation ddx at the front. So ddx and then copy the question. Okay. And then, so look at here. So differentiate cos, it is negative sign. Remember the previous example. And then inside here, we have 5x minus 4. So here this notation, just to know, to mention that we have still to differentiate this one. So after we differentiate this one, we got 5. So 5 we bring to the front. So the final answer would be negative 5 sine in bracket 5x plus 4. Okay, so that's for the first question. Right, next for the second question. So here, differentiate sine ln x. So we have inside sine we have ln. Right. So look at here. So look at the highlighted here. Okay, if you notice here, we don't differentiate ln yet. We just differentiate sine first. So differentiate sine will get cos. So inside here, still we follow the original inside function here. There is ln x. And then after that, then we mention that we still need to differentiate ln. Okay, understand? So I repeat once more. First, we differentiate trigo, the outside. Inside, we still have ln. And then multiply. Then here we differentiate the ln. Right. So differentiate ln, we know it is 1 over x, right? Remember the previous video. So 1 over x. So our final answer, cos ln x. So since over x, just put over x like this one. Okay. So very simple. Alright, next, differentiate of tangent pi over 6 minus 3x. Right. As I mentioned before, first we just differentiate the trigo. So differentiate tangent, remember the previous example, we will get secant squared. And then the function here, we still copy the function. We don't differentiate yet, this one. So we still have pi over 6 minus 3s. And then later, at the back here, so we mentioned that we still need to differentiate this one. So differentiate at the back here, we know pi over 6 here is constant. So constant doesn't affect when we differentiate, we'll get 0. So only with the variable. So here negative 3x, so differentiate this one, will get negative 3. So we put negative 3 at front here. So our final answer, negative 3, and then follow the above, the in front there, that is, we already know it is secant square. So negative 3 secant square pi over 6 minus 3s. Okay, right. Next, the last question, we have secant in bracket 2x plus 3. Remember, as I said before, we differentiate secant first. So differentiate secant, will get secant tangent. So after secant and tangent, don't forget you just you have to write down the inside function here, that is 2x plus 3. So 2x plus 3 also here. And then later at the back we differentiate 2x plus 3 and we know it is 2. So we put 2 at the back at the front here. So the final answer would be 2 secant 2x plus 3 tangent 2x plus 3. Okay? Right. So next, what will happen if we have power at trigo function? So let's see what happened. So as we see right here, we have 3. I think the most suitable term that I will have to use here is 3 layer. 3 layer of differentiation. First, we differentiate power. Okay. And then second, we differentiate trigo. And then lastly, we differentiate inside function. Okay. So you get here, the first one, we differentiate power. We still have sign. This sign that we don't differentiate yet. We just differentiate the power. Okay. So I note here, I put a notation here. Still we have original trigo. And trigo here, still original inside function. So remember, for differentiation, we have to differentiate accordingly. We just layer by layer and not differentiate all at once. So remember, I repeat once more, in this kind of situation, we differentiate layer by layer. So the first one, we differentiate the power. So trigo function remains. And then second, we differentiate trigo. So inside function remains. And then lastly, we differentiate the inside function. Okay. So that's the concept or derivative of sine power of n u, and so on for cos and also tangent. Okay. So the formulas much more or less will be same, but remember, you have to differentiate layer by layer, as I mentioned just now. Right. Now in example 18, so here we have 3 questions. So the first question A, y equals to secant squared. Notice, this time we have y equals. So no need to put ddx, so just straight away dy dx, okay? So dy dx, remember first we differentiate power. So secant remains, and then we differentiate the secant itself, and then later we differentiate x. Now differentiate x, no need because x is 1. So we just through layer of differentiation, that is differentiate power and trigo function. So the answer would be, the differentiate secant would be secant tangent. So secant, we already have secant, differentiate power, and then from trigo we have secant tangent. So secant and secant here, we can simplify, and then we'll get secant squared. So the final answer would be 2 secant squared x and tangent x. Okay, next for question B. So for question B, we have sine squared. So for sine squared, we differentiate power first. So differentiate power, we bring power 2 and bring as coefficient 2 at the front. And then at the back here, we still need to differentiate trigo. So differentiate sine. And then don't forget, later on, we have to differentiate the inside function here. So here we have 3 layers of differentiation. Power, trigo, and inside function. So power already settled. So we still have a need to differentiate trigo. So differentiate trigo would be cos. Differentiate sine will get cos. And then don't forget, we have to copy original function, inside function. And then here, the product from, it's not actually product, but yeah, maybe the product also suitable. The product from differentiate inside function, that is 2x. Differentiate x squared will get 2x. Okay, so here we have the answer from the 3 layers of differentiation. So how will we simplify this one? Right, we notice at the front we have 2 and at the back we have 2x. So we can bring 2x to the front and we'll get 4x. So the final answer will get 4x sine x squared plus 1 cos x squared plus 1. Okay. Okay. And then lastly for question C. So for question C, so remember for question C, we have cotangent power of 3, the original question. So differentiate power, so 3 we bring to the front, we get coefficient 3, and then power reduced by 1, so cotangent squared, right? And then we still have to differentiate the trigo function, so differentiate cotangent. Remember what is the differentiate of cotangent? Check the formula. So differentiate of cotangent would be negative cosecant squared. So here, this is the answer from the power, differentiate power. So here the answer from differentiate trigo, right? So we combine together. So not much, we just bring negative to the front. So the final answer would be negative cotangent squared cosecant squared. Okay? So that's all from example 18. Right. So that's all for this video. Thank you very much. And remember, don't forget to answer all the tutorial questions regarding trigo function. Until then, thank you.